So at first it looks like a really simple problem. You have y equal, looks like a simple problem, y equal cosine 1/2 of x, and you want to rotate that around the x-axis from 0 to pi. Okay, and find the surface area. Looks like a pretty simple problem. Right? If you had to graph it, you would, well, first thing you would do is you'd find the period, which is 2 pi over omega, omega being 1/2. So you would graph it from 0 to 4 pi. Okay? So from 0 to 4 pi, let's say this is 1, 2, 3, 4 pi. You know cosine, it goes from 1 to -1 like that. You know what cosine does. Cosine starts and goes down and goes down and goes up and goes up. This is what cosine does. So if you divide it into 4 parts, you would see what cosine does. Now we take the first part and we rotate it around the x-axis. Pretty simple. Rotate it around the x-axis. So this graph would look something like that. So that's the surface area that we're trying to find. From 0 to pi, rotate it around the x-axis. Okay. Straightforward. So if we know that y equal cosine 1/2 of x, then dy dx would be -1/2 sine of 1/2 of x. Okay. And the arc length would be the integral, the square root of 1 plus dy dx squared dx. So that would mean the arc length is integral square root of 1 plus -1/2 sine of 1/2 of x squared, and then dx. No problem. If we simplify this, it would be the integral square root of 1 plus 1/4 sine squared of 1/2 of x dx. Okay? Now, if we're doing the surface area, we know the formula for surface area is 2 pi, the integral, we're going to do it from 0 to pi, or 2 pi y, in that case y is cosine of 1/2 of x, and then the arc length, which is what we just found, the square root of 1 plus 1/4 sine squared 1/2 of x dx. So that's the arc length. Okay. So unfortunately, we don't have a du easy here. So what we're going to do, well, what we're going to do here is let's call u sine x. Let's call u sine x. sine 1/2 of x. In this case, du would be 1/2 cosine 1/2 of x, okay, dx, which we almost have here. We have the cosine of 1/2 of x dx, but we're missing the 1/2. Okay, so we're going to add a 1/2 here. So we will have it, and then we're going to multiply by 2, so we don't change the problem. Okay. So this integral will be now 2 pi. We can put the 4 pi. We can put the 4 pi outside. The integral of square root of 1 plus 1/4 u squared, and then du. Okay. Now we need to change the endpoint, since u is sine of 1/2. So instead of 0, we're going to change what is the sine of 0. Sine of 0 is 0, so it's still 0 here. And then pi, so we're going to have sine of pi over 2, which is 1. So this will be from 0 to 1. When you change the variable from cosine 1/2, you go to u, you need to change the boundaries as well. Sometimes we do the problem and then we go back to x. But this is not that type of problem. This problem will go so far, we have to probably make another change. So I don't want to leave the endpoint. I'm going to move the endpoint. Whenever I change the endpoint, instead of waiting for the last minute and then go back to x. Remember, we used to say the problem is not about u, it's about x, so we go back to x. But let's change the endpoint. And now we forget about x. It's all about u now. Okay. Yeah.
You said something about changing those points in.
We never changed them before. Huh?
I remember you saying something about changing them in calculus 1.
Yeah. Sometimes we do the problem and then we go back to x, so we don't have to change the endpoint. But this is a complex problem, so I'm going to, every time I change, I'm going to change the boundaries. Okay. All right. Let's make this simpler. So the 4 pi is there. The integral from 0 to 1. This time, I'm going to put common denominator here. So I'm going to say this is 4 over 4 plus u squared over 4 du. Okay? Which I can separate. I can say 4 pi, the integral from 0 to 1, of square root of 4 plus u squared over 2 du. Square root of 4 is 2. So I can separate the numerator and the denominator, and then I can simplify the 2. So now I have 2 pi there. So this is really 2 pi, the integral from 0 to 1 of square root of 4 plus u squared du. So remember this trigonometric substitution. Sometimes we change with sine, not this one. Sometimes we change with secant. Sometimes we change with tangent. This is the one that we probably want to change with tangent. Yes? Sure. So let's call u, let u equal 2 tangent theta. Let u equal 2 tangent theta. In this case, du is going to be 2 secant squared theta d theta. All right. So now what I have here is 2 pi, the integral, I'm going to change those boundaries again, square root of 4 plus u squared, which is 4 tangent squared theta, and then du, which is now 2 secant squared theta d theta. I need to change the endpoints. Make a decision. Do I want to change the endpoints now, or do I want to go back after to do it? We could change the endpoints right now, because the endpoints are 0 and 1. So we can find theta. When u equals 0, so 0 equals 2 tangent theta, okay? That means tangent theta equals 0. Where is tangent 0? Tangent is 0 at 0. So I can say theta equals 0. So it's going to be from 0. Okay. Now, when is 1 equal 2 tangent theta? Because the other boundary is 1. So that means tangent theta equal 1/2. When is tangent 1/2? We don't know. We can either leave it like that, like arctangent of 1/2, or we can go back at the end and change it. But I'm just going to put arctangent of 1/2. Okay, we'll deal with that. That's not our major concern right now. We can always come back and fix this. Okay. Now let's simplify this. We have 2 pi. The integral from 0 to something of the square root of 4, I factor 4, 1 plus tangent squared. 1 plus tangent squared theta. And then, don't forget the d theta, 2 secant squared, 2 secant squared theta, d theta. All right? Square root of 4 is 2. 2 times 2, 4. 4 times 2, 8. So I really have an 8 outside, 8 pi. Integral from 0 to something. Square root of 1 plus tangent squared theta. And then secant squared theta d theta. 1 plus tangent squared is what? Secant squared. So this is 8 pi. The integral from 0 to something. Square root of secant squared theta. Secant squared theta d theta. All right. Square root of secant squared, I can say it's secant. So 8 pi. The integral from 0 to something, secant theta, secant squared theta, d theta. It's not something that we know, so we might want to do integration by parts to solve this problem. So I'm going to call u secant theta, because it's easy to find the derivative of secant theta. Derivative of secant theta is going to be secant theta tangent theta. And then I'm going to call secant squared, I'm going to call that dv. Because I know the function that gave me secant squared is tangent. All right, so I can do that to find the integral. So what I'm going to do here, I'm going to leave the 8 pi alone. I'm going to solve this, and then I'll come back and add the 8 pi, because 8 pi might give me trouble here. So let me solve this. So what I'm trying to solve here is secant x, secant theta, secant square theta, d theta. I'm going to solve this with integration by parts, which means uv, u being secant, v being tangent, secant theta, tangent theta, minus the integral of v du. V du, which is tangent theta, secant theta, tangent theta. Tangent theta, secant theta, tangent theta, d theta. All right. Simplify this. This is what I'm looking for here. Secant theta, secant square theta, d theta. And I say it's equal to secant theta, tangent theta, minus the integral of tangent, secant, tangent. I may need to do another integration by parts here. I may need to do an, go ahead.
What if you made that secant squared theta into 1 plus tangent squared? Would that
Which one?
be easier? Under the integral term at the start,
So,
instead of doing integration.
okay, let's do that then. So I'm going to say this is secant theta, and then tangent square theta, d theta. Okay. Instead of doing integration by part, let me change this tangent square theta. Okay. So I have secant theta, secant square theta, d theta. I already say it's equal to secant theta, tangent theta, minus, this time I'm going to change, like you said, I'm going to change tangent theta into what? What is tangent theta equal to?
1 plus secant.
Secant squared. Tangent squared is secant squared theta minus 1 d theta. All right. Let's distribute the secant. We have secant theta, secant squared theta, that's what we're looking for, d theta, is equal to secant theta, tangent theta, minus, we have another integral of secant theta, secant squared theta, d theta, plus the integral of secant theta, d theta. The nice thing happened here, I have secant square theta in both sides, so I can move this one on that side and solve for it implicitly. You know, it's not like we could not find the integral, but we can simplify it. So, what do we have here? We have 2 integral of secant theta, secant square theta, d theta. It's equal to secant theta, tangent theta plus the integral of secant theta, which we know, d theta. That we know. What is the integral? So 2 integral of secant theta, secant squared theta, d theta is equal to secant theta tangent theta plus ln of, we should say absolute value, but we're not going to bother with that, ln of secant theta plus tangent theta. Okay? So the integral that we were looking for, the integral of secant theta, secant squared theta, d theta, which we were looking for, will be secant theta tangent theta plus log of secant theta plus tangent theta, everything over 2.
Sir, did you ever hear that?
Okay. When I simplify the 8 pi, I get 4 pi. So we are in the case where u is 2 tangent theta. Yeah? U is 2 tangent theta. So our triangle will have opposite is u. And adjacent is 2. And this would be the square root of 4 plus u squared. Right? Are we okay with that? All right. So when somebody say 4 pi secant, 4 pi, when somebody says secant theta is going to be 1 over cosine, so the square root over 2. So the square root of 4 plus u squared over 2. That's the secant. Times u over 2 times tangent. So secant times tangent plus log of secant plus tangent. And we'll do this from 0 to 1. All right. So this is 4 pi square root of 4 plus 1, 5 over 2 times 2, 4 plus log of 4 plus 1 square root of 5 over 2 plus 1/2. Minus, we do it for 0 now, 4 pi square root of 4, which is 2, times 0, well, that's goes that part, plus ln of square root of 4, which is 2 over 2, 1, plus 0, that goes that part as well. So this whole part goes. So the final answer is 4 pi square root of 5 over 4 plus ln square root of 5 plus 1 over 2. Let's check with the calculator. 13.07 is the surface area.